example. The previous chapter we factored, right? So we know how to factor. So once I give you that quadratic equation, you can use it to factor, right?
Right.
Yeah. What kind of method? AC method. Good. So what is A and C in here?
1 and 2.
1 and 2. How do you know? What is the standard quadratic equation? Standard.
AX squared plus BX plus C.
AX squared plus BX plus C equal to 0. So A implies here in 1. The C implies here in 2. That's why A times C is 2. So what two integer pair?
2 and 1.
2 and 1. So we can use it to factor out x plus 2 times x plus 1, right? And then put the equation notation. Then if I ask you about the two solution about the quadratic function, you can tell me x equals -2 and -1 as your two solution, right? Everything's good so far? But now we are looking at the function. Function has input and output, right? So we have input here, but then output we have to make it. So in this chapter 10, we're looking at the quadratic function, which means you have power of 2 equation, but then you need to put y equals here, because we are looking at input and output there, their relationships, right? So whenever you're making a t-chart, x and y, if you plug in 0, 0, 0, and then you got the 2. So that is the function input, and you also have output, right? So that one is basically quadratic function, and I want you to make sure that in chapter 10, quadratic function, it will be same A as your leading coefficient, it will be same B as a constant coefficient of the x, it will be same C as a constant. So it doesn't change anything. A means leading coefficient, B means middle term of coefficient, C means constant, right? So whenever I said A is positive, which implies that number is positive value. Okay? When I said C is negative, that constant might be negative. Okay? Alright. So I told you about that there is a lot of math vocabulary today. So one of them is a parabola, right? No, before we do this, let's graph that y equals x squared, which is parent function. So y equals x squared, here is possible x values. There is some negative, there is 0, there is 1 and 2. If I plug in 0, what do I have for y? 0. What about 1? 1 times 1? 1. 2 times 2? 4. Negative 1 times 1? Negative 1 times negative 1? 1. Negative times negative makes you get positive. So 1. Negative 2 times negative 2?
4.
4.
Oh, that's right.
Do you see any pattern in here?
Yes, I do.
Except that it's got same y value, it will get the same y value, right? Jordan, do you have any question? Negative times negative turns to positive. So let's plot the point. I think everyone has that smart curve. Erase the exponential function. Then let's draw the quadratic function, which is parent. Y equals x squared. Plot the point 0, 0, 1, 1, negative 1, 1, 2, 1, 2, 3, 4, negative 2, 1, 2, 3, 4. So connect the point, it will get a smooth curve. Do you see how it looks like? What it looks like?
Like a U.
Smile.
Which
Smile.
That's exactly how
Smiley face. And also any alphabetical letter.
I said
Yeah.
U.
You.
U. It's more like a U than
The
V.
first thing.
B will be the absolute value function, something like this. So that one is we're gonna study in algebra 2, not 1. So we are looking at a smooth curve, U shape. Yes, exactly on the word. The parent function, U shape. Good one. So here's special name. The U-shaped graph of the quadratic function will be parabola. Are you guys first time to heard about the parabola? No?
Yes.
Last year?
I did not
We
hear
did
this.
not.
I didn't hear this last year.
Yeah, I never
So this special name, parabola, is will be U-shaped. Keep that in mind, U-shaped. And then here is my question. How do you find a U-shaped something in your real life, in our life? Smiley face,
Alphabet.
alphabet U.
Whenever you're texting someone.
I have a hint.
A face.
St.
I already
Louis
said that.
Arch, right?
I knew it.
What about?
Arch is
That's not it. Taran taran.
McDonald's.
McDonald's. Right? Something like that. So I have kind of cool video to share.
Why do I have two I don't like it. Ew, he isn't a sucker.
Okay, let's look at this. Where can you find the parabolas?
On it.
Graphing equations.
Do you want to listen to music or
I
not?
like this.
You don't have the song.
I wrote this song.
Are you guys gonna dance?
I wrote this. No.
Did you remember the vortex version? The dolphins. How many seconds dolphins hit the water?
No, you
Last chapter, right? Vertical version. Also,
I hate. I've never.
amusement park.
Oh my god, you scared.
St. Louis Arch is very famous example.
I think we should go to St. Louis, because that's
Oh my god.
Why does it know lyrics?
Let's make upside down. That's the point of it. Here is the parabola.
What's the point of 26
Now
it's all mathematical.
No lyrics.
How many of you played basketball?
I do. Referee time.
Basketball is a parabola. If I give you a candy to
That'd be me.
Oh, I'll take it. I can catch it. I can catch it. Oh, no, I can.
later, we have a lot of candy problems.
Okay.
If I throw away something, it looks like a parabola. Then
It's a skydiving.
Oh, are they? Daddy, that is me. No, I can't hide it.
parabolas are everywhere. Wherever you move.
Yes. Yeah, like they're like.
McDonald's, see? McDonald's. Told you. Rainbow.
I was gonna say.
I've never seen it.
Golden Bridge.
It's a lot.
In San Francisco, right?
Yeah, that's me.
Even in place you don't expect. If you stretch a lot,
That's more like a V.
we.
Oh, when Mario runs, he jumps far but not high.
There is
That's the next video.
a parabola in everywhere in real life. That's why we must study that chapter, right? Right? No?
Yeah.
Yeah. So here's again we are parent function y equals x squared. Here's more math vocabulary. One is vertex. Vertex is the lowest or highest point of a parabola. And Sam, can you point out which is the vertex in that?
The lowest point would be 0, 0.
Yes, it will be 0, 0. So Sam did really good job because she said as an order pair 0, 0, which is the point. So whenever I ask you about where's vertex in particular quadratic graph, you will say 0, 0 or 2, 0, something like this in the order pair, not just saying over there. Okay? And then axis of symmetry is new word as well. Lines of symmetry. There is a line. There is a imaginary line that passes through the vertex, and it also divides by exactly in half. Where is that? Nate?
The y-axis.
Y-axis. Y-axis. In particular case, is that y-axis. But did you guys remember that in the equation, y-axis also we can written by x equal to 0, right? So keep that in mind. Y equals 0 is the common lines of symmetry in that chapter. So if I ask you about the axis of symmetry, you will say y-axis, either in the equation you will get x equal to 0. Okay? So what else? What is the symmetry in the real life? What else?
A mirror.
Mirror, right? Whenever you see mirror. What about the person's face?
Sometimes.
Butterfly is really
Sometimes
good
one
one.
eye is bigger than the other eye.
Butterfly.
A bowl.
Boar.
What?
A what?
A
Ball.
boar.
Oh, I said a bowl, but yeah, bowl works
Boar
too.
works. Anything?
Rainbow.
What about this?
No.
Heart.
Well, not a real heart.
Exactly, symmetry. So,
The real heart.
circle. Okay.
Real heart is like
Yeah, there's really a lot.
I didn't really get
It was an
Axis of symmetry.
Oh, I thought you were just
I grabbed
talking
Oh, I
to
love
me.
my that's
Okay.
That sucks.
Axis of symmetry. Y-axis. There is the line. X-axis will be the lines of symmetry. Keep that in mind. X equal to 0 is in equation. In equation, you will say x equal to 0. It's the same meaning about the y-axis. Right? Okay, so let's think about that one. I think you guys can guess what I'm gonna talking about whenever you're looking at the picture, right?
Are these people
Symmetry.
like their bodies
Smiley faces.
This is the way to remember the difference between parabola opens up and opens down. But an easy way, you know, when your leading coefficient is something greater than 1, which means it's usually a big number, 2, 3, 4, right? -3, -3, -4, something like this. When you have positive A number, you will get a smiley face in your graph. See here, smiley face. The way to remember is whenever you're looking at the positive, something thinking positively, you will smile, right? Sometimes you got the 100 score in math test. You will smile, right? You will smile, which means positive. If you got A equals positive, you will smile. What about
Power of your glasses.
when A equals between 0 and 1? I mean, I'm sorry, oops. That one was not. Just A was equal to 0, positive. And A was negative, you will get angry face, sad face. So, for example, one of the example, y equals 3x squared, it will be smile. Y equals negative 3x squared, it will be sad. Something like that. So, I want you to graph y equals x squared plus 5 on your graph paper. X squared plus 5. And then also compare with the graph of x equal to y equals x squared, which is parent function. So here is your y equals x squared, and then I want you to draw the new one to compare these two.
Wait, that's why squared.
The way to graph is create your t-chart. Sure. Raise your hand if you wanted to have new marker.
Actually, mine's fine.
Just in case.
Plus 5.
Did you got any smiley face?
I didn't. Yeah.
I got a smile.
Because your A is 1 in that case, so 1 is positive smiley.
I was supposed to get it. Yeah.
Okay, I think that's something weird. Okay, so I did like
Really high.
Big shot.
Oh, I thought you were just going like that.
Let's make the teachers together. 0, 1, 2, negative 1, negative 2. If I plug in 0, what do I get? 5. If I plug in 1, what do I get, Jessica? If I plug in 1 for x, what is your y? 6. Okay? What about 2? Chloe? 9. Because 4 plus 5 is 9. But here is my question. If I know a parabola is always symmetry, right? Like a mirror. It will be always symmetry, right? Should I find out that value or should I copy that? Copy is better idea, right? Probably just copy it. Because it's going to be symmetry, for sure. So, if I plot as point 5, 6, 9, 6, 9, so a smiley face. My parent function will be like this. My question is, what do they have in common? Nate?
They both have the same line of symmetry.
Yeah, same line of symmetry, which is x equal to 0. They have same line of symmetry. Good job. What other common thing? They have
They're both smiles.
smiley face because they are all has 1 as a coefficient. 1 is positive, that's why they are all smiley face. Smiley face. What do they have in different? difference between these two? Sam.
Their vertex.
Their vertex. What is that vertex?
0, 5.
0, 5. What about here?
0, 0.
0, 0. Awesome.
What is that?
Vertex.
Is that right?
Yeah. Vertex is all you need to do is looking at the bottom point. Bottom point. In that case, if you have arch, you're looking at the top point. What else? Do they have different vertex? Is that only point to moving up to the 5 unit? Is that only point? Or point has to be moving up to 5? What I mean is, vertex is different. It goes up, right? What about the other point? It also goes up, right? So, can you guess what it looks like if I give you y equals x squared minus 5 instead of positive 5?
It's a frowny face.
It's, yeah.
No, it's not. It starts at negative 5, but it's still smile.
It's starting at
Would you like my
negative 5, but then it'll be still smiley face, and also have same lines of symmetry. So, since the negative 5 in here and the positive 5, notice that difference is it's just moving up and down. The C is important because it makes it graph up and down. Doesn't change anything, but up or down. Positive 5 makes you up. Negative 5, the graph goes down. In the same unit. Make sense? Okay, what about y equals 3x squared? Let's draw that. Since we're going to compare to y equals x squared, so don't erase that one. That one is the basic
I don't think
quadratic.
I erased
I
that.
erased that a long time ago.
But it's not that hard to re-graph. X squared.
I feel like it looks really weird because like I feel like it's like that.
If you don't this point, the graph goes like that.
Because okay, so I have
0, 0, 1, 3.
Okay.
Because square first and then multiply.
Oh, okay. Square first?
Guys, you have to square first, right?
Yeah, because exponents always go first.
Order of operation, square first, after that multiply by 3.
Okay. That's
graph on the calculator, right? Oh. Jordan is really
Yeah, he is. He's crying.
Do you see here? This is Jordan's work. This is exactly same as the answer key. See here? It's a really good job. See here? Jordan, how do you think about what do they have in common?
They have the same vertex.
They have same vertex, which is 0, 0, which is good. Also, do they have same lines of symmetry?
Yep.
Lines of symmetry, same. But what is difference about something? There is big difference. I can see something really
They don't have the same.
big, tall,
Sure.
tall. If I assume this is the Mr. Parabola, if I assume this is the Mr. Parabola, then he is really skinny, right? Right? Yes or no? This is Mr. Parabola. He's getting skinnier.
Wait, what?
I mean, the original function is y equals x squared. He has a standard weight so far. He has standard. But then after making multiply 3, then see he's skinnier than before, right?
Oh.
You lost weight,
Multiply by
Mr.
something
Parabola.
What's Mr.
So can you guess? How can make him to more skinnier?
Take away the 3.
Multiply by
Multiply by 5.
5.
Oh,
Let's multiply by 5. Then he will get much skinnier, right?
You multiply by 7.
Much
I'm gonna write
If you multiply by 7,
I said 7.
We.
really skinnier,
About
right?
10.
I think he's anorexic.
Do you know what I
Or
mean?
bulimic.
You will get
I don't know what
really vertical stretch, which means it's skinnier, or you could say it's narrower than before.